Hi everyone, I'm Amy Zimmer. I'm so sorry we didn't get to actually chat today for our collaborate session. It's my luck that it was down for maintenance for my very first one, but I did want to talk to you today a little bit about forensic alcohol testimony because that's where really my specialty lies. I was a criminalist for over 8.5 years in forensic alcohol and narcotics, so analyzing drugs for their narcotic components chemically and instrumentally, and also for forensic alcohol, testing all of the samples for DUIs in the city of San Diego. And so that would include both blood and urine, as well as doing breath testing and testimony in those areas. So it's a really important one because I think a lot of times people are unaware of how much a standard drink can affect an individual in terms of impairment, and how many drinks it would take to get to what we call the illegal limit, which is a 0.08 in California. So first of all, what is alcohol? Ethanol is grain alcohol. It is the alcohol that we drink. There are other types of alcohol out there that are much more potent in terms of concentration. Things like isopropyl alcohol, which you would not want to drink. That would make you very sick. But what is it? It's a drug, and it is called a central nervous system depressant. That means it slows down the activity of the brain and therefore your physical functions as well. And those are both mental and physical, are very important for driving, as you might imagine. So the driving is a multitasking activity. So a person is trying to concentrate on their central visual task, which is to maintain the lane. And there's also those peripheral things that are going on in and out of the lane and speed control. And so the ability to track with the eyes is very important. And so when a person's under the influence of alcohol, all of those functions start to slow down, and the person is not able to multitask, divide attention, and react as quickly as they would with zero alcohol. So first of all, how does alcohol get into the body? We know that we drink alcohol. It goes down into the mouth, into the esophagus, into the stomach. About 20% of that alcohol gets absorbed by the stomach, but the majority gets absorbed by the small intestine. And that's because there's a very rich blood supply in the small intestine. The small intestine, because it has a rich blood supply, has a lot of water. And alcohol is water-loving. It likes to diffuse directly across the membrane and go into the blood and get circulated around until it's in equilibrium with all parts of the body. So the heart, liver, lungs, brain, and all muscle tissue. And that happens relatively quickly. It can reach the brain within 1 minute after consumption. And how does it get out of the body? The process is called excretion or metabolism of alcohol, and that happens for the majority in the liver. It actually breaks down alcohol into very simple components, carbon dioxide and water, essentially. 95% of that happens in the liver, and the rest of it comes out unchanged. So if you smell somebody walking by that smells they're reeking of alcohol, it's actually coming out of their pores unchanged in the concentration that's actually in the body at the time. Also the breath, that's why breath testing is utilized in California, because it is equivalent to what's going on in the body, in your bloodstream. So elimination rates, we don't have absorption rates, but we do have elimination rates, and the liver can only process so much per hour. So the elimination rate is between a 0.01 and a 0.02 per hour per person. So it really doesn't depend on gender. It doesn't depend on, oh, trains going by. It doesn't depend on height, weight, or gender. And this is because the liver can only do so much per hour. Now that's not the case with a standard drink. It will raise women and men differently, and that's because our water components are different. It has to do with muscle to lean tissue and body water. Men have more body water, women have more body fat, unfortunately, which means it's more concentrated. A standard drink is more concentrated in women than it is in men. So if you're drinking, a woman is drinking with a man and they're drinking at the same rate, she's going to have a higher level overall than he will. In terms of how alcohol gets into the breath, I told you that it comes out unchanged in places like sweat, urine, breath, even breast milk. If women are breastfeeding, if they're drinking alcohol, that comes out unchanged in the milk. So how does that work? Alcohol is a volatile. So just like you inhale oxygen, you exhale carbon dioxide, ethanol can be exhaled as a gas. So basically in the lungs, it's a heated environment. It's an environment that's contained, and it can diffuse directly across from the blood into the breath and be exhaled out with the same concentration that's going through your bloodstream. So that's why breath testing is accurate. Although breath testing slightly underestimates the actual amount in the body, and that is because a person has to give a physiological sample. So imagine if I'm just sitting here and I get a sample taken from my blood, I'm not doing anything to influence that particular sample. It's coming directly from my system. However, with breath testing, the person has to take a nice deep breath, exhale for a certain amount of time with a certain amount of pressure, with a certain slope, meaning over time with enough volume in order for it to register. And so because of that physiological variability, the samples tend to be on average about 10% lower in terms of quantitation. So it's actually to the benefit of the defendant or subject to do a breath test, because it will be slightly lower than what's in the bloodstream. So in terms of how alcohol affects the body, I told you it's a central nervous system depressant, slowing the activity down in both the brain, which is the mental impairment, and also in the physical components, so things like fine motor skills and then ultimately gross motor skills. It's surprising when you look at people that are very tolerant of alcohol, meaning they can drink quite a bit and not show some of those outward obvious physical signs of impairment like slurred speech or instability, coordination, things like that. It's because they're used to functioning with alcohol in the system. And I'll give you an example. I was asked to come down to the Sally Port, which is where all of our potential suspects are brought in to do testing for all kinds of things, 11-550s, which would be drugs, and then for breath testing for alcohol. And I had a subject that, an older gentleman, probably in his late 50s, reeking of alcohol, but could still talk and walk, obviously impaired. His level, when he blew through the breath hose twice in the Intox Laser 8000, was at 0.42. And legally, that person, generally, a person at a 0.42 would be in a coma or would be dead. So that just shows you how well the body can accommodate and process and become tolerant to drugs in the system when it needs to be. So talking about small levels of alcohol in the body immediately starts to affect the eyes. And as you can imagine, the eyes are very important for driving. This is what we're relating it to all of the time, is driving. So a person adjusting the rearview mirror, adjusting the radio, slowing down, speeding up, shifting, checking peripherally, in and out, depth perception, how far, how close, all of those things, because the messages from the brain are slowed down to the body, that person is not able to react in time. The other thing is called divided attention, which is the big one we talk about a lot in court, which is the ability to do more than one thing at a time. And that's what driving is a multitasking event. So when a person's not able to do that, they will focus on one thing rather than multiple things. So you might see a person on the freeway who's staying in their lane, but they're going 30 miles an hour because they can't maintain both. Or they're going the speed limit, but they can't stay in their lane. So that's an example of multitasking or divided attention, where a person is not able to do those things. And so in the beginning, a person feels, in the very low levels of alcohol, feeling of relaxation, good feelings, loss of inhibition, maybe not as alert, joyous. And then it turns into more of the gross motor skills, which would be things like reaction time, instability, coordination, slurred speech, and then it can progress into things like blackout. We see this a lot in sexual assaults. We call them brownouts to blackouts. Brownouts can be where an individual can remember parts of the night, but can't piece together everything that happened. And blackouts are completely gone, where they've lost good chunks of the evening. I had that in a homicide where two brothers had been drinking large amounts of alcohol, and they were both jiu-jitsu experts, and got in an argument about the brother's estranged wife. And essentially what happened was, when they started fighting, the younger brother was losing, and he grabbed a kitchen knife and as I don't know if the other brother came down and he landed on him or he actually stabbed forward, but it punctured through the pleural cavity, and the brother ended up running around through the apartment until he eventually collapsed, basically drowning in his own blood. I did the alcohol analysis on the brother, the suspect, in the morning when they discovered that this had happened around 11 a.m., and he was still a 0.05. So doing calculations, which we'll talk about in a little bit, which is called retrograde extrapolation, to put him back at the time of the scene around 8 p.m. when this actually happened, he would have been around a 0.26 to a 0.30. So think about that. The legal limit to drive is a 0.08, and he's well over 3 times that amount. And he did not remember parts of that night. So, and that's because he was in such an alcoholic state, as well as his brother. Time of death, brother was a 0.24, so they've both been drinking pretty consistently that night. So that tells you a little bit about how alcohol can affect the body. So we talked about mental impairment and physical impairment and how important those things are for driving. And I testify a lot to that in court. And I wanted to talk to you a little bit about why the 0.08 level has been established. And National Highway Traffic Safety Administration and American Medical Association, and so many correlation studies. Those are studies that look at alcohol and how they're related to impairment. And I've actually done 2 studies myself where we've measured, given measured doses to individuals and then done divided attention tasks, which is much easier than actually driving, to see how that would affect a person. And it's pretty phenomenal. Even at the lower levels, at 0.05, people are still affected in their driving, which puts them at risk and then also puts the public at risk. In other countries, it's a 0 tolerance. Here, for under 21, obviously it's 0 tolerance, but in other countries, they're saying now that even a 0.01 is not allowed. So that's interesting. We'll see how the law changes. Now, in terms of a standard drink, we use this in calculations in court a lot to say how much would one drink raise an individual. And we want to define that because when we talk about how many drinks are in this person's system at the time of driving, that's critical. If I tell you there are 15 drinks in this person's system right now, that's pretty powerful. That tells you that person's not just having a casual drink or 2 with a friend, they're drinking a considerable amount and then jumping behind the wheel. So a standard drink is defined as 1 1/4 ounce of 80 proof. Proof means, 80 proof means that it's half alcohol, 40%, half of that. So when you hear 100 proof, that's not 100% alcohol. That means it's 50% alcohol, 50% water. And when you look at things like moonshine, when you get to almost 200 proof, that's almost 100% alcohol, which is terrible for the body. Eats your liver alive, as well as your stomach lining. So most hard alcohols, gin, vodka, whiskey, things like that, are usually 80 proof, which would be 40% alcohol. So an ounce and a half to an ounce and a quarter shot would be considered 1 standard drink, which would raise a person the same amount as would a standard glass of wine. So a 5-ounce glass of 12% wine, those 2 are equivalent. As the same as a 12-ounce beer, which is between 3 and 5% alcohol. Even though the volumes are different, the alcohol quantity is the same. So if I drank that beer or that wine or that shot, it would raise my level the same. And again, it's not the same for women and men. It's very different. So for example, I'll just do a calculation for you, my pink calculator for court. But when I used to do these calculations, I would take into account a couple of things. Female versus male. That's the first one, because the water distribution in my body would be less than a man's. Height and weight have been shown to affect the overall rise per drink, as well as what's called a Rho factor. And the Rho factor is the ratio of body water to blood water. So women have more water in their blood, less water in their body. So when it gets distributed, it's much more concentrated than in a man. So for a standard drink for me, I'm going to do the female calculation. So I will do my weight. I'm not going to tell you what that is, my height. And let's do a 50%. And 1 standard drink raises me about a 0.03 per drink. So if I have 0.03 per drink. Let's say I have 5 drinks. I'm at a 0.15. I'm almost twice the legal limit. Now remember, most people don't drink that all in one dose, so you have time to eliminate over time, which is a 0.01 to 0.02 per hour. But that would take me almost 10 hours to get rid of. So that's quite a long time. For a man, the same amount, let's do a male who is 200 pounds and 6'2", let's say, and that would raise that person at 0.016. It's almost half. A person my size, I'm 5'4", 125, I'll just tell you. For a man that is 200 pounds and 6'2", is almost half that. So if we're drinking at the same rate, 0.016 times 5 drinks, he would only reach a 0.08. So much different, right, in terms of how much that would affect males versus females. Okay, let me move forward in my notes here. I want to make sure I cover everything. So how do we look for impairment? Officers have been gone through coursework to determine at roadside if a person is in fact impaired. So these are called field sobriety tests. And FSTs, there are several. You may have seen people outside of a vehicle and they're doing this type of thing, or they're tilting their head back and counting. Those types of tests are fine, but there are 3 standardized tests that are used out in the field that are very effective. Now remember, being impaired doesn't necessarily mean alcohol alone. It could be paired with another drug. Typically marijuana is the one that we see that's combined with alcohol, or it could be completely unrelated. It could be hydrocodone. Let's say this person took too many Vicodin. You get very similar results. Slow reaction times, people's pupils are either enlarged or dilated. They're dilated or they're restricted. They may have nystagmus, which is a jumping of the eyes. So the 3 main tests that they look at are horizontal gaze nystagmus, which means that they're going to hold their finger in front of the person's face so that the person can see the tip of the finger, typically 12 inches away, and they're going to sweep it across the horizontal plane, and they're looking for, as that gaze goes across, is there bouncing. That's called a nystagmus. So there are 3 things that they're looking for. At the extremes, are they bouncing when they hold it at that far extreme? Is there a lack of smooth pursuit? Are the eyes maybe not catching up with the finger? And at 45 degrees, if it happens earlier rather than just at maximum, that person is probably more impaired than the 0.08 level. And that's really accurate. And the person doesn't know that they're doing it. It's an involuntary response. So that's what makes it so good, is that the person can't try to control it even if they have tolerance. And so, again, that nystagmus is an involuntary jerking of the eyes. It kind of looks like marbles across sand. It's very bumpy, very easy to pick out. And what's happening is the messages to the brain are slowed down to the eyes. So when the finger starts to go across the plane, the eye is trying to catch up with the finger. And therefore, you can see the jumping of the eye. It's really neat to see out in the field. I've been on a couple of DUI ride-alongs, and it's very easy to spot. The other 2 are called the walk and turn. You've seen them walking the line down a certain number of steps, turning, and then walking back. That one can be dangerous if someone's very impaired. I've seen people fall into trees. I've seen them obviously step off the line and have difficulties with that. So you want to make sure that it's safe for that person to do that. Also the one-leg stand, having the person point their toe and lift their foot off the ground for about 30 seconds, and normally a person is unable to coordinate that and cannot estimate 30 seconds of time. So those give the officer information to be able to proceed and say, I think that this person is impaired for the purposes of driving. I smell alcohol on this person. I'm going to go forward with my investigation. They can use something called a PAS, a preliminary alcohol screening device, which is a handheld device used out in the field. It's preliminary, meaning it gives you an idea of what their level is, but you don't use it in court as a confirmatory test, at least not in San Diego. And there are some that have technology which allows for safeguards. Your question this week, the discussion question for the discussion board, has to do with safeguards for evidentiary tests, which would be the breath tests. And why are those so important? So I'm going to discuss some of those to help you with your discussion board, but you must have those in place, otherwise it invalidates the test. So if the person agrees, it's a voluntary thing. If they say, sure, I'll take a PAS device, let's say the person registers a 0.12, down to the station you go, and you get a confirmatory test. If they say no, and the officer thinks that they are unsafe to drive, down to the station you go. Once the person gets there, they have a choice. They have a choice of breath or blood. We used to use urine as well, because I told you before, alcohol comes out unchanged in the urine. Here's the problem. Let's say I'm drinking consistently for 5 hours, and I have 5 drinks. Where does that leave me? Puts me at a 0.15, right? But 5 hours of time has passed. Let's say it's a 0.02 per hour that I've eliminated. So by the time the 5 hours is done, I'm probably around a 0.05, 0.06, okay? Because I didn't drink it as a bolus or a whole dose. I had 5 hours of time. But what if I didn't urinate? So in my bladder, I'm collecting everything from my body, unchanged. So my bladder says, my urine says, a 0.15. But my blood would say a 0.05. So what the problem is that instead of voiding the urine, that means you empty your bladder and wait for it to fill back up about 20 minutes and then take a sample, they were getting inaccurate results, which were way inflated. That's not what was in the system at the time, and it's just not as accurate as taking blood directly or taking breath from that deep alveolar lung air. And so the choices, again, breath and blood. So the breath test that we use in San Diego is called the Intoxilaser 8000, City of San Diego. Other agencies use other types of breath tests that are approved by the Federal Registry, which means they've been tested and calibrated and all of those things to ensure that they work properly. And they do something called Trombetta tests, which look at breath tests and blood tests from the same individual and show that they are equivalent to each other. And that's how you can show that these are successful in either manner to be accurate and reflective of what's going on in the person's system. So the breath test is obviously less invasive. The Intoxilaser 8000 uses infrared technology to measure the amount of breath, alcohol in the person's breath. So think of it this way. If you are driving at nighttime, and let's say your headlights are infrared light shining through, and there's no fog at all, and it's completely a clear night, and you shine your lights and it hits a stop sign, we'll call that the detector at the end of the instrument. So if you shine your light, all the light goes through, nothing gets impeded or absorbed. That would be a person with 0 alcohol in their system. But let's say on a foggy night you're driving. What happens when you shine your lights through? Some of that gets absorbed by the fog and less light reaches the detector at the end. That's the same principle here, is that the less light that is received at the detector at the end, the more alcohol in that person's system. And it can turn that amount that's absorbed into a quantitation, and that's what infrared light does. It absorbs and transmits light through molecules the same way every time. So ethanol is very specific and has specific wavelengths in which it will absorb and transmit. And so the more absorption you get and the less transmittance you get, the higher the level. Now, in terms of safeguards, pay attention. In terms of safeguards, Title 17 is the California Code of Regulations, which tells us how we can collect and preserve and analyze alcohol accurately. And so under Title 17, there are a bunch of different rules that we need to follow. And one of those is the officer has to do an observation for 15 minutes before they actually give the person the breath test. And that's to ensure that nothing's been consumed, nothing's in the mouth, they didn't eat, drink, burp, regurgitate, anything like that that could potentially affect a breath test. The Intoxilaser 8000 that we use, it wouldn't affect it anyway because we have something called a slope detector, which I'm going to talk to you about in a second. So the 15-minute wait. In addition to that, you have to have some sort of testing prior to the person actually giving a sample because you want to make sure that the instrument is working properly. So the person, before they can even do anything, it has to go through air blanks to ensure there's no ambient alcohol in the air around. it has to go through a diagnostic check to ensure that all the parameters that are going to test the subject are working. So things like enough memory, things like the printer paper, the infrared source, all of those things are functioning. Once those pass, there's more air blanks. Then there's something called the calibration check. It actually has to pull in a known concentration of alcohol in a gas form and test it. It's a known level. Let's say it's a 0.10. If that instrument does not accurately test that gas within a certain range, which is our uncertainty range, it's very, very small, 0.003 difference, then it would fail and you couldn't go forward. Then there's more air blanks to ensure there's no alcohol within the system. You have a heated breath tube so that when you exhale the alcohol, it stays as a gas and doesn't return into a liquid in which you originally consumed it. So it stays as a gas into the heated chamber, which is an additional safeguard. The person has to exhale for a minimum of 4 seconds, 1.1 liters, and a particular 1.1 liters is the volume over the 4-second time frame, and then hit a particular slope with a particular pressure. So there's 4 things going on there. And what I mean by slope is you're watching on the screen in real time. So you'll see 0.04, 0.09, 0.16, 0.20, 0.20, 0.20. So notice what happens with the slope. It has a slope, it has a gradient to start with. It's going up, 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 0.20, 0.20. Now it has a 0 slope. This is indicating as a slope detector that this is the actual level and it will capture a sample at that particular point. So let me turn this off. There we go. So in capturing that sample, you want to ensure that that is the highest level and the maximum level that is going through that person's system at that time. 2 more air blanks, and they give a repetitive sample. And why would that be important? Because 2 samples, one could have been a fluke. By chance, maybe it was something else, who knows, an interferent. Couldn't have been an interferent because it has an interferent detector for things like acetone and other types of alcohols. So it's able to discriminate between ethanol and other things. So certainly that wouldn't be a factor, but just to make sure, it's always good to have a replicate, just like in blood testing. We do 2 tests to ensure that that's the true level, and then more air blanks, another diagnostic check, another calibration check, and then it prints out. So it's quite lengthy, but it's the non-invasive way to go, and it's reflective of what's circulating through that person's system at that time. The other type of testing is blood testing, and we use headspace gas chromatography. So if you guys remember from reading, chromatography is the theory of separation. And so in this particular case, we take a small 1 microliter sample of blood and dilute it with 1,000 microliters of a standard. The standard is a known concentration of another type of alcohol. So we're diluting this blood sample in a vial and heating it to an equilibrium. And what we're doing there is ensuring that the alcohol that's in the blood down here on the liquid portion is the same that's in the gas portion up here, just like in your lungs. You're ingesting liquid alcohol, but the gas in your lungs, that volatile, is what we're actually testing. Same thing with the blood. We wouldn't want to put blood through the capillary because it's so tiny. It's like 2 millimeters thick, and to try and get blood through there would gunk it up. So we actually sample the gas. Now, if a person had no alcohol in their system, we would see, for chromatography, 1 peak. That's the standard that we added to the sample. It's called N-propanol. We know that concentration. We would see no alcohol, and then bloop, a peak for N-propanol. But if there's alcohol in the system, we would see a peak for ethanol, and then a peak for N-propanol. And because we know the N-propanol concentration, we can calculate the concentration from the areas under those curves to see how much alcohol is in that person's system. Now, in the blood vials themselves, when the person has a tube taken, there's both preservative and anticoagulant. You want to make sure that it doesn't clot, because that can change the concentration when you pull blood away from the serum. And also for preservative, to make sure there's no bacterial growth, because that could cause fermentation. And you would know if that happened because the tube would probably explode and it would smell, and you would know. So that's why we have both of those things. And blood is called the gold standard in testing for headspace gas chromatography because it is extremely accurate out to 4 decimal places. So we use that quite frequently. So other than that, I think that's pretty much it. Let me just review my notes, make sure I covered everything for blood and breath. Oh, one other thing I wanted to mention before I go, because I talked about the calculations, but I wanted to talk to you about the calculation I mentioned has height, weight, and gender, and a rho factor, which is that blood and body water ratio. It's called the Widmark equation. And Widmark came up with this equation more so to determine calculations for the person at the time of driving. So let's say the person's pulled over at midnight, but they're not tested until 2 a.m. They've lost alcohol over that time, right? Over a 2-hour period, they've eliminated probably at least a 0.04. So if they were at a 0.16 at the time of driving and now they're at a 0.12, that's very different. So we do something called retrograde extrapolation, where you calculate back in time to see what the person might have been. And certainly they would have been higher earlier in the night, because as you start to eliminate, it's a linear relationship. 0.02, 0.02, 0.02, until you get down to 0. So what retrograde tries to do is go back in time to say, look, they weren't a 0.08 at the time of driving. That was the time of the test. At the time of driving, they were a 0.12. And that's very different in terms of the law. So that can only really be used, it's mathematically sound, but as long as you know things like the amount that was consumed, the times it was consumed, when they stopped drinking, was there food in the stomach? So there's all kinds of factors that you'd want to know before you actually employed that calculation. Because if the person wasn't fully absorbed and they were still kind of going up and then evening out and staying at an equilibrium at the time, maybe the time of the test is the same as the time of driving. So you wouldn't want to overestimate what they were at the time of driving. So anyway, I think that kind of wraps it up. That's a lot in a 30-minute period. If you have questions, please feel free to reach out to me, and I hope that we can do a collaborative session together. It was really unfortunate that we weren't able to have a dialogue today, so I'm hoping to meet some of you before the class actually ends. So I'll look ahead and see what I can schedule. I took off time from work to come home to do this darn collaborative session. So hopefully that helped you, at least with the DUI portion, forensic alcohol as a toxicology. It's toxicology. It's not complete, but it's for alcohol quantitation. So I hope you really enjoyed that, and I will talk to you guys soon. Have a good one. Bye.